Okay, so this video is going to deal with physiology of the cerebrum. Okay, we talked about all the various lobes, but now we need to what's their function? What are they doing? And there are three types of function. We have motor areas that are going to control our muscles and our glands. We have sensory areas that are receiving in that information from all those sensory organs around the body. And we have association areas where we're making the connections between things. For example, I tread on a piece of rubbish on the floor. A piece of Lego really hurts, and I'm thinking, ow, has that cut me? Do I need a band-aid? 2, which child left that thing there? 3, how many other pieces are around? 4, who do I call to come pick it up? 5, how can I stop this from happening again? Why haven't all the kids done their chores? 6, that reminds me, we need to reorganize the toys in general, and and one sensation then leads to lots of stuff. So that's in our association areas, connecting stuff, and not just the simple firing for them. This is the action that needs to take place, but that association of the input information and the output information. Okay, and that's just on my conscious level. Anyway, I could go on for more than that, but I won't. Please remember that in my left hemisphere, I'm controlling the right side of my body. I'm doing the wrong side. In my right hemisphere, I'm dealing with the left side of my body. In my left hemisphere, I'm dealing with the right side of my body. So that's to be remembered, that we're dealing with the contralateral side of the body when it comes to the brain. And we need to learn when that crossover takes place. Where do those nerve fibers actually make the switch? Because they have to. And that's important for damage. If we damage the right side of our brain, is it affecting the left side of the body? Well, depending on where the problem is, maybe. Okay, a lot of that crossover comes in the brainstem. So then the next point is that we have this lateralization. In our left side of the brain, we deal with logic and language and math skills and those sort of things. Logic, language, math skills. On the right side of our brain is much more our artistic sort of side of things. So what do they say we put on there? Emotion and the visuospatial stuff. So we have this lateralization of language and logic and maths, and then the artsy emotion, visuospatial type of stuff is on our right side of the brain. But to re-emphasize conscious behavior, if you are aware of it, that is somehow in the cortex. The whole cortex is involved with that in some way. So now we need to learn about the specific lobes and what they more specifically do. We have the frontal cortex here. That is generally about our character and about judgment. We discovered this quite early on because people did frontal lobotomies and mashed the frontal lobe and discovered that their behavior would change. Which might be good if you had a mass murderer and you wanted them to not go around killing people anymore. But one of the side effects from this would be that they would stand up and they would just go to the toilet in the center of a room because they didn't understand that that was not appropriate behavior. So the idea of that judgment, is this acceptable for this situation? That's decisions that are made here in our frontal lobe. This is a lot of association cortex. It's difficult to sort of say this neuron's doing this and this neuron's doing this. These are working on spatial tasks and recall, and it's difficult to actually say exactly what's going on here, but it's a lot of judgment and character. The frontal lobe, though, is a very large lobe, and it goes back as far as the central sulcus. And when we talk about the central sulcus, we'll see that there is a gyrus anterior to the central sulcus, and it is the most posterior part of the frontal lobe. This is our primary motor cortex. All the neurons here are involved with sending signals out to make muscles move. Generally skeletal muscles. For the main part, they're skeletal muscles, but it's our primary motor cortex. Anterior to that, we have a premotor cortex. This is the association cortex for motor movements. So in my head, I think, pick up a cup, and to do that, I know I need to put my hand around the cup and lift it. But although I'm consciously thinking of doing that, I'm not consciously thinking of how much I need to use my deltoid muscle and how much I need to use which muscles in which fingers and all of that. But the premotor cortex is actually doing all of that connecting for me to then be able to go back and fire the correct muscles to do the movement I think I need to do. Okay? I said earlier that balance is done in the cerebellum, and that would be it. So I could actually keep my balance on this ball, because I'm sitting on a ball. Then all that balance stuff for me to actually hold my core muscles correctly, that would be more done in the cerebellum. But it's a coordinated effort. So there's the primary motor cortex, you fire these and particular muscles fire, but all that connection between the different muscles that are useful is done in that premotor cortex. Okay, if we have a primary motor cortex, we also have a primary sensory cortex, but we call it somatosensory because that's coming from the body. It's not our special sensory organs, it's not hearing, it's not sight, it's not taste, it's our somatosensory. So it's our primary somatosensory cortex. Soma means body. Yeah, and that is in our post-central gyrus. Here's the gyrus. Here's our central sulcus. This was our pre-central gyrus. Here's our post-central gyrus, and that's got our primary somatosensory cortex. So coming from our limbs, etc., all the muscles, coming from information from the skin and from our muscles and from our joints, this is all coming back to here. We also have a somatosensory association cortex behind that, posterior to the post-central gyrus. And that's our association cortex for the sensory information. Okay. We also have a primary motor cortex for speech here in our frontal lobe. And that is called Broca's area. And this is a motor cortex for the muscles of speech, to be able to make the words and make the sounds. So damage here is going to stop you from being able to make the sounds of the words. It's not going to stop you from being able to understand the words, but it's going to stop you from being able to speak them. We also have an area called Wernicke's area, or Wernicke's area, in our parietal lobe and into the temporal lobe, and that is the area where we make sense of language. So it's not our hearing. Our hearing is actually found in the temporal lobe. The primary auditory cortex here is in our temporal lobe, which makes sense because it's just under the ear. But to make sense of those words or to make sense of those sounds, we will do that in this Wernicke's area here. We also have an association area for hearing, and that's just posterior to the primary auditory cortex. So for hearing and for speech, we have lots of different areas to make sense of it. And that becomes very important for people who've had strokes and they're not able to do a particular part of the speech process. So some people can hear, but they can't make sense of the words they're hearing. They can speak what they want, but they don't make sense of the information coming back in. Other people are not able to make the words themselves. They can't speak the words, but they do understand what other people say to them. Yeah, and this is part of the fun of speech therapy, actually understanding where the problems are and how you can help somebody to improve. But as you can see, this is very complex, the amount of information we have in our cerebrum. And we're just scratching the surface, I do tell you. Okay, so which lobe, which cortex? Motor and premotor is in our frontal lobe. Sensory and the association cortex for somatosensory input is in our parietal lobe. Vision, most of you, well, maybe you know already, vision is done at the back of our cerebrum. That's in our occipital lobe. Taste, gustatory input comes into our insula. Hearing, as I said, is in our temporal lobe, and smell, olfactory, is also in our temporal lobe. And yep, this I would expect you to know. Okay, so what did I say about the frontal lobe? I said that was mainly about your personality. Mash the frontal lobe and the personality is changed. In your parietal lobe, you're mainly dealing with somatosensory. Temporal lobe is then hearing and smell. Occipital lobe is vision. And insula, even though I said taste is in the insula on this slide, the main thing that people associate with the insula is actually emotion. Okay, so I do expect you, I do expect you to know it this way around, which cortex is found in which lobe, but I would also expect you to tell me what the main function of each individual lobe of the brain is as well. And if I said insula, I would expect you to say that was emotion. Okay, we're going to come back and I'm going to talk about the pre and the post central gyrus a bit more. Thanks.